Welcome back, folks. So in the last video, we talked about what standard form of a quadratic function looks like. So standard form looks like so. Standard looks like f of x is equal to ax squared plus bx plus c. And of course, a cannot be 0 because otherwise you actually just have a linear function. Alrighty. Now, factored form is actually a little bit different. And so I'm not going to talk about where this comes from in terms of like how you get there. But I just want to show you why it's useful first, and then the question, how do we get there, will be, nagging at you, because you're going to really want to be able to find the factored form. Okay? So, and we'll talk about why this is helpful. So the factored form, I'm going to say f of x, because it's still a quadratic, is going to look like this, and we're just going to use an example. Okay? So we'll just use an example here. Actually, we're going to do an example of both of them. Okay? An example here, an example here. So these are going to be two different functions. We're going to draw f of x right here is equal to negative 2x squared plus 4x minus 3. Pretend. Okay? And this one over here, we're going to call this one g of x. The factored form looks like this. 2x, we'll just say, actually make it kind of simple here. We're going to say x plus 3 and then x minus 4. Okay. Now the reason it's called factored form is because you have taken the equation, the standard form, and broken it up into factors, something times something. Okay. So that's why it's called factored form. And also the way you get from here to here is you use the process called factoring, which again we'll get to in the future. Okay. So let's actually try our best to sketch these functions. So for this one, now, we don't actually know much. What we do know is that we have the y-intercept right here. Again, so when I plug in, to find the y-intercept, I'll plug in 0 for x. I have 0 plus 0 minus 3, so that's really just negative 3. Okay, so I'll draw this right here as best I can. Something like this. So our y-intercept is at negative 3. I'll draw it like so, negative 3. And we do know that a is right here. Negative 2 is less than 0, so it means it does go downward, frowny face style. But other than that, I don't really know anything else. Okay, so I do know it's frowny face. If I want to find the x-intercept, actually let's save all this information for later. To find the x-intercept, I would have to solve this equation. Remember, to find the x-intercept, you set y equal to 0, so you're really setting f of x equal to 0, and you have to solve this equation. Oops, sorry about that, we ran out of space there. As of right now, I have no idea how to solve that equation. So we're kind of out of luck here. And so I don't really know much about this graph. All I know is that it's got a y-intercept of negative 3. Negative 3. And it goes downward like that. I actually don't even know how many x-intercepts it has. It might be something like this, or it might be something like this even. I really don't know much from this. Well, let's take a look at the factored form here. Okay, well, I can find the y-intercept pretty quickly. Now, it's not as obvious as the last one, but to find the y-intercept, you're still plugging in 0 for x. So we're going to evaluate g of 0. It's not too bad because it's 0 plus 3, which is 3, and 0 minus 4, which is negative 4. Equals negative 12. Not so bad. A touch more work, but really not that bad. Now, I could find the x-intercepts as well, even though it doesn't quite look like it. But again, we're going to start off by plugging in 0 for y, or for g of x, equals x plus 3, and then x minus 4. And so what you're going to want to do here is kind of step back a tad. And really what you're looking at is 0 is equal to something times something, a times b. Now you might remember this little thing, you might have learned this in middle school or some other math class, but the only way to get a product of 0 from multiplying is if one of the factors that you started with is 0. Let that seep in for a second. So what this means is that either this equals 0 or that's equal to 0. And so this is going to be an equation with two solutions. So let's see. X plus 3 is equal to 0 if x is equal to negative 3. And x minus 4 is equal to 0 if x is equal to positive 4. And so these are our x-intercepts. And notice that this is a parabola because it curves. It actually has two, whereas a linear function only has one at most. So this is a parabola, and therefore it has two x-intercepts. It might have less than 2. It might have 1 or 0. But this one happens to have 2. And so if I was to create a table, by the way, well, actually, let's sketch what we have so far. So from the factored form, we have our y-intercept and x-intercept. So I'll draw this. By the way, because, sorry, we'll kind of leave that there. Our y-intercept is at negative 12. So let's see. Oh, this is a little awkward here. I'm going to go by 2s. 2, 4, 6, 8, 10, 12. Negative 12. I'll go 1, 2, 3, 4. I did not plan this very well. 2, 3. Gonna look like this. Now notice, because we already know where the x-intercepts are and the y-intercept is in relation to it, we actually know exactly the orientation of this thing. It has to be smiley face. Right? It couldn't be frowny face. It wouldn't work. How can I fit this but still hit 12? It'll have to come back, but it's not a function. Anyway, so this has to be like so. Okay? Something like that. Okay, the last thing we want to point out is we actually can find the vertex of this. And check this out. To find the vertex, I'm going to create a little table here. So what we know, we don't know too much. We know x, y, or f in the output. We do know that when I plug in 0, I get negative 12. Oops. But that's not really helpful here. What I'm going to plug is I'm going to plug in negative 3, and I know our output is 0. And when I plug in 4, positive 4, the output is also 0. If we think back to the video previously, we remember that this part right here, this line of symmetry, goes through the vertex, oopsies, and is right in the middle of those two x-intercepts, or it's symmetric, remember. So for example, if this spot is some units away, then this x-intercept is also the same distance away. And so the vertex is actually going to be right in the middle of those 2 points. So the question is, what's the middle of negative 3 and positive 4? Well, the way we find the middle of two numbers is also called the average of two numbers, and that's going to be equal to adding them up and dividing it by 2. Oops. And so that's going to be at, let's see, positive 1/2 right there. And now that we know the x value of the vertex, so again, that's just the x value, we can plug it in to find the y value. And so the y value would be like so. Let's see, that'll be at 3 plus 1/2, so that would be 7/2, times, let's see, 1/2 minus 4, which would be at, let's see, that's going to be a little harder. 1/2 minus 4 be at negative 3.5, so that's 7/2 again. Negative 7/2. Alrighty. Alright. For some reason that looked awkward, so I have to just double check myself, but that looks pretty right. And so this y value is actually going to be at negative 49/4, which is about, where is that? That's about negative, that is exactly negative 12 1/4. Alright, so it's just a little bit below 12, which is right around there. And that's going to be our vertex. Okay. So actually the factor form is actually a lot more helpful than the standard form. From the factor form, you could find the x-intercepts using the property here, and this is called the zero product property, or the ZPP. You can use those x-intercepts then to find the vertex, because the vertex is going to be right smack in the middle of them. And you could easily find the y-intercept again by plugging in x equals 0. Okay? The only question now is that if I'm given the equation in standard form, how do I get it into its factored form? And that's where we're going next. Alrighty? So thanks for watching. I'll see you in the next one. Bye, folks.